Hello everyone, thank you all for coming today, and thank you to the organizers for allowing me the chance to speak to you guys. I will be talking to you about Polywrap. So Polywrap is a project, it's fully open source, it's governed by the Polywrap DAO, and it's being developed by the Polywrap DAO. And before I jump into talking about what Polywrap is and what it does and how you can use it, let me first start off by talking about the Web3 space today. So today, Web3 is all about decentralized networks and peer-to-peer networks. This is the backend or the backend API of the Web3 space. With decentralized applications that are normally just, front-end React apps probably running client side, they connect to these blockchains on the back end. Since computation is really expensive on chain, this means that when you want to talk to a protocol that's running on a chain, you generally want to create some kind of SDK around that protocol. So basically wrap that SDK. And by doing that, you delegate all of your computation to the client. And this brings us to the Web3 integration problem. So every day, well, lately every hour, there's a new Web3 protocol that spawns. And all of these protocols have some kind of SDK that wraps them. So on the front end, that's probably a JS SDK. On the back end, that's a Go or a Rust SDK. And this is the Web3 today. It's a whole bunch of JavaScript SDKs. Oops. So what's the problem with JavaScript and just traditional SDKs today? And this applies to both Go, Rust, Python, C#, every kind of SDK. They are, firstly, not multi-platform. This means if you write your SDK in JavaScript, you cannot easily run it in something like Go or C#. This means that you have to rewrite all of your SDKs in any language that you wish to use. And if you're just a developer that's not working on a protocol and you want to integrate some kind of protocol into your app and there's not a JS or there's no SDK for it, that means that you have to write your own SDK. Additionally, they are insecure. So today, apps or dApps have dozens, hundreds, or even thousands of different dependencies. Those dependencies have dependencies of their own. The example I like to use is Hardhat, which is a CLI tool that you use to deploy and build your contracts. So Hardhat has 50 dependencies. And if any one of those dependencies gets hacked by some kind of malicious actor, then your whole app is exposed. Sometimes even your whole system, if it's running on a production server or your user system. So if one of these hard hat dependencies gets hacked, that means that the hacker can maybe read from the file system, and if you're keeping your keys there, he can get them, he can send them off to a server somewhere, and that's how he gains access. So traditional SDKs are not really secure. They're not scalable. So JavaScript SDKs, especially since they're running on the front end, you generally just embed them in your app or dApp, and you just deploy them somewhere. This really bloats your app. It decreases performance. It increases load times. So they're not scalable. Additionally, and lastly, they're not standardized. You can create or define an interface for your SDK with any kind of methodology. You can use functional programming, object-oriented. You can create all these kinds of approaches to defining your interface and how you create objects that interact with your SDK. Especially if you're talking about SDKs in different languages. So let's say Aave creates a JS SDK and a Go SDK. These two SDKs, even though they do the same thing in different languages, have different interfaces, they look different. Sometimes they even have a bit of a different functionality depending on when they have been developed. And depending on the language, they can have certain intricacies, certain flavors of that language. So here comes Polywrap. So the Web3 integration problem is one of the problems that Polywrap solves, and it's the best example I have to explain what Polywrap does and how it functions. Polywrap enables developers, so you guys hopefully, to build your SDKs, which I use the term SDK, but really this is any program, any kind of logic in any language, and you can then run those programs on any platform in any language. We do that, or we can accomplish that by using WebAssembly. So WebAssembly is really cool because first off, a lot of languages support it. So, for example, Go, Rust, AssemblyScript, all of these languages you can use to compile down to WebAssembly. So you can use them with Polywrap. WebAssembly also can be run on any device, whether it's mobile, IoT device even, because WebAssembly modules are really efficient. They're really small, fast. And most modern languages support running WebAssembly modules. They're also sandboxed by default. So this means that your dependencies cannot just gain access to your whole system or to the user system. They cannot just interact simply with each other or even the outside world. This is also one of the pain points of WebAssembly, but here at Polywrap we have devised a way to have those modules be able to talk to each other and to use certain system capabilities like HTTP or WebSockets, the file system, multi-threading. Also, we use decentralized storage. So how do you run a Polywrap-enabled app? So to enable Polywrap in your app, you need to download the Polywrap client in the language that your app is built in. And the Polywrap client is responsible for fetching these wrappers, as we call these Polywrap SDKs, so these WASM modules. The Polywrap client fetches those wrappers and then executes them locally on the client side. So even though you can use Polywrap and load those wrappers from HTTP or from the file system, you can even embed them just like you would traditional SDKs. Generally, here in the Web3 space, you want to use decentralized storage. So that's something we also support with decentralized storage networks like IPFS or Arweave. And if any of these solutions does not work for you, we're highly modular, so you can write your own resolvers. These are pieces of code that you can use to fetch your wrappers from any kind of external source. With Polywrap, your app can become infinitely scalable. So the problem with traditional SDKs, especially in front-end apps, a good example is DeFi aggregators. So to be able to integrate all of these DeFi protocols, they often use backend APIs, which you can integrate any amount of backend APIs into your front-end app. You will not bother to your app. But that also means that your code is being executed on a centralized server somewhere. This also means that you cannot use it in your decentralized app. So with Polywrap, you can use IPFS to download your wrappers. The client has a cache and a garbage collection system so that you can recycle those wrappers that are not being used very often. You can keep the heap size very small. And that's how you can add on any number of SDKs without actually bloating your app. We also use GraphQL. We do not support GraphQL queries, so we use something more similar to RPC calls to communicate between wrappers or between the client and a wrapper. But we use GraphQL as a schema definition language. It's actually our own sort of extension on top of GraphQL, so the language is really GraphQL-like. And GraphQL is great because it allows easy onboarding for developers, because most developers know how to use GraphQL, hopefully. So we use that as our interface definition language, our schema definition language, so that you can define your wrapper interfaces in it. And any interface for a wrapper, no matter if the wrapper was written in Go or Rust or AssemblyScript, looks the same and feels the same. So we have standard interfaces which allow easy composability between those wrappers. You can even define standard interfaces similar to how you can, if you're familiar with Ethereum and EIPs, you have ERC standards. So for example, the ERC20 standard, which is just a definition of an interface. And then you can design your ERC20 implementations based on that standard, that interface definition. In the same way, you could define a standard interface for a wrapper. Maybe that wrapper is an AMM, for example, and then you can create any amount of actual wrappers that are implementations of different AMMs that all have the same interface. So these are the three pillars that Polywrap is built on: WebAssembly, decentralized storage, and GraphQL as the schema definition language. This is how the Polywrap experience looks like. So this is the golden path of usage for Polywrap. You wrap any protocol. We use the term protocol, but that could be any kind of routine, any algorithm, any logic. You deploy it to decentralized storage solutions like IPFS or RWeave. It's not something that's forced upon you. This is just the golden path in decentralized apps, but you can use HTTP, you can use the file system. Like I said, you can embed those wrappers in your app. And then you can integrate these SDKs on the client side on any platform. So even on something like an IoT device or a backend app. So you can imagine if there was an ecosystem maybe of SDKs, of wrappers built around, let's say, automated market makers, and it was only for the front end that those wrappers were used. You could still reuse those wrappers on the back end in your Go app, or even if you're building some kind of decentralized network, you could use those same wrappers that are used on the front end, you can use them on your nodes. So going point by point with the earlier drawbacks of traditional SDKs. So traditional SDKs are not multi-platform. With Polywrap, you can use your SDKs everywhere. You can write SDKs in almost any language. So Go, Rust, AssemblyScript. For those of you that don't know, AssemblyScript is really similar to TypeScript, but it compiles to WebAssembly, since TypeScript cannot natively compile to WebAssembly. And you can even have a team of developers. Maybe one part of the team works on Go SDKs, so Go wrappers, and another part of the team works on Rust wrappers. And all of them can be used in a single JavaScript app or a single C# app. Again, traditional SDKs are insecure. If one dependency gets hacked, all of the dependencies and the whole system is hacked. But since we use WebAssembly, all of these SDKs, all of these wrappers are sandboxed. They can still talk to each other. They can still use certain system capabilities like the file system and HTTP. But that all goes through the Polywrap client, which means you can really, when you configure your Polywrap client in your app, you can control the flow of information, the permissions. Using my previous example of Hardhat, let's say we rewrote Hardhat as a wrapper. When installing, you could be asked for, to give it permissions to the file system or to HTTP, for example. And you can even have more granular permissions. So for example, with Hardhat, since it's just used to build contracts and deploy them, you can just give it permissions to access your file system only for the project that you're running it in, and maybe you give it access to the HTTP capability only for the node that you're trying to connect it to. So if one of the Hardhat wrapper dependencies gets hacked, that means that your whole system will not get hacked because they will not have permissions to do almost anything. So not scalable versus infinitely scalable, since we download these wrappers normally at runtime. Again, not a requirement, but that's just the golden path with Polywrap. You download them at runtime, you cache them locally so that you can re-execute them. If you're using something like IPFS, that means you're using content addressing, and you know that your wrappers that are hosted on IPFS will not change, so you can safely cache them and reuse them. You can use something like ENS if you want to give your IPFS URIs a more human-readable name. So you can use ENS for maybe dynamic updates. So every time you query an ENS domain name, that redirects to an IPFS hash where the wrapper is stored. You can get that wrapper back, and every time that ENS domain name updates, you can get a new version of your wrapper. And with GraphQL that we use for our schema definition language, you define your interfaces in the same way, no matter the language, so that you can define things like standard interfaces, and you can really build open source wrappers, open source SDKs. So again, just a one slide comparison between these points. And are you ready to build? So starting off, if you are an app developer and you want to integrate Polywrap into your app, you need to install the Polywrap client. So this is really similar to how you would enable HTTP in your app by installing an HTTP client. We currently have a JavaScript client and are working on a Rust and a Python client, which will be coming soon, as the slide says. So to install your Polywrap client, you just run npm install, or maybe use yarn. Next step, you configure your Polywrap client. So you import it, you instantiate a new instance of that object, and here in the constructor is where you would really pass in the arguments to that constructor, and you would configure all kinds of plugins or permissions or different system capabilities that your wrapper can have, or your Polywrap client will have, and will enable your wrappers. So how do you actually execute a wrapper? So a wrapper has a unique ID. Each wrapper needs to have a unique ID. Generally, that's the URI of the place where you have published your wrapper. So for example, if you're using IPFS, that would be the IPFS hash. If you're using ENS, so you published maybe to IPFS and then you register that IPFS hash on ENS, then you have an ENS domain, so that's what your URI is. So you call the query method on the client, you specify the URI, which is your ENS domain name of your wrapper, and then you write a GraphQL query. So here we have a mutation, and we're calling a swap method, and we're swapping some ETH tokens to uni. So with this, it's really easy to use. On the back end of it, you're just really doing RPC calls to that wrapper locally. So the client first fetches the wrapper from IPFS, downloads it, and executes it locally. So any protocol is just a request away. So this was from the app developer side. So from the wrapper or SDK developer side, you have the build process, the build experience. It's really just two steps. You define the schema, which is your interface of your SDK, of your wrapper, and you define the logic of that wrapper. So the interface is in GraphQL, well, a GraphQL-like version. So we support some custom syntax to make your life easier. Here we have the query module. We have a method called method and an argument called argument. It's really creative. That argument is of custom type, and below we define that custom type. So this is how your interface would look like, and it would look like that the same in any language, whether it's written in Go or something like Rust. On the right side, we have some assembly script logic. So we define that method and what the method does. Here it just returns the property of the argument that you pass it. So it's really straightforward. But the most important thing here to note is that our CLI that you use to build these wrappers supports a codegen command. So before building, you would run codegen in your project directory, which would look at the interface of that wrapper, and it would parse it and generate types for your assembly script project. or for your Go or Rust project, if you're using Go or Rust. And that's what the W3 folder is for. That's the Cogent folder. It's called W3 because we used to be called Web3 API. We have since rebranded to Polywrap, but we have yet to update our code base fully. You can see we're importing the custom type here, and that's an assembly script type now because it's code generated. We are also importing the inputs for the method, and it's an object. It's not just passing arguments to that method. This is just to support any kind of accidental breaking of backward compatibility. For example, if you had two arguments in your method and they were both strings, so maybe an address and a name, and in the newest version of your wrapper you switch their order, this wouldn't cause a build time error, but it would cause a runtime error. But when you don't have a list of arguments, but you have an object which has named properties, then you do not have this problem. So that's what the input argument is. This slide shows you how to actually call another wrapper from your wrapper. So I showed you earlier how you could call into a wrapper from the client, so from your app. But from a wrapper, you would first need to import that third-party wrapper into your own wrapper. So you do that in the schema. So here we have an API domain.eth, which is some wrapper that we deployed to ENS. And we import it into our schema. And then the Polywrap CLI goes to ENS, it redirects to IPFS, fetches the schema of that third-party wrapper, downloads it, and when you run the cogent command, it will generate types for that third-party wrapper. So on the right side, from the W3 folder, again, which is the cogent folder, you import the API query, which is the query module of that wrapper. We, again, call it API. We used to be called Web3 API. And you just call some query method on that wrapper. So it's really similar to how you would call a wrapper from the Polywrap client. And that's how you compose different wrappers together. On this URL, you have a demo of the Uniswap v2 SDK written as a wrapper. So you can swap some tokens, and in the code, we are using the Polywrap client, and we are using the Uniswap version, the wrapper version of the Uniswap SDK, the V2 version. We also have a V3 wrapper, but I don't think there's a demo of that yet. So just on the front end, from the UX side, nothing is different. But if you open the developer tools, you can, on the network tab, see that it's fetching wrappers from an external source. In this case, I think it's fetching them from IPFS through the IPFS IO gateway. These are some of our launch partners. We have an active launch partner program. We work with them to see how we could solve some of their problems with Polywrap. And if you want to apply, you can contact us. Polywrap.io is our website. Polywrap_io is our Twitter. Follow us, browse our docs, integrate, join, and thank you for your attention. Any questions?
So you said which languages can you write wrappers in right now?
Yep. So which languages can you write wrappers in? Okay, so to write your wrappers, you can currently use Rust and AssemblyScript. AssemblyScript is really similar to TypeScript, so it's great for TypeScript developers to onboard to writing WebAssembly modules. And the next language we would support is Go.
So it's basically like any language that can compile down into WebAssembly, right?
So yeah, any language that can compile down to WebAssembly, you can use that to build your wrappers in, but you need explicit Polywrap support. You could add your own support for that, or you could wait for us to implement it. Yeah. On the other side of that, there's also the languages you can run those wrappers in. which is currently JavaScript. There's a JavaScript client, and we're building a Rust client, and I think it's a Python client, yeah.
And what does the roadmap look like for language support, for example, on either side? Like, could you elaborate a bit more on that?
Sure. So the roadmap on the language support on both sides, not all languages support compiling down to WebAssembly, so we cannot use something like JavaScript or TypeScript. So, like I said, we support AssemblyScript, we support Rust, next up is Go. After that, I don't think we have any plans. But for the client side, we support JavaScript, or TypeScript, of course. Then Python and Go are being developed in parallel. Python and Rust, and after that it's Go. And I think after that will probably be C# or something else, but that might be done in parallel as well.
Thanks.
Cool. Thank you for your attention.